Wednesday morning to you. This is our Wednesday edition of the map discussion, and the attention grabber is this cyclone that we've been forecast. It's been forecast pretty well. It's over the Ohio River Valley, Tennessee River Valley. There's a line of thunderstorms currently making its way through eastern parts of Tennessee. There are no severe warnings that I see, but some very heavy rain is accompanying this storm system, and this is all part of a massive shortwave, I guess you could say, that's embedded in this long wave trough. Here you can see the little lines, the little kinks in the red lines. This is 500 millibar heights. So this is pretty much this is a geopotential height. It's the distance between a mean sea level and where the pressure reaches 500 millibars. And the lower the heights, typically the cooler the air. So when you see these little kinks here, that means that in front or just to the east side of those kinks, you'll have some enhanced lift associated with a surface frontal boundary, which is what you just saw draped over Tennessee. This is the water vapor imagery overlaid with these 500 millibar heights, and it shows very nicely, if we were to go through the images here, it shows very nicely where the disturbances are in the upper parts of the atmosphere. This is what it looks like on the surface map of the GFS. You have this frontal boundary here that's been draped over the mid-Mississippi River Valley into the Ohio River through the Tennessee River Valley. And you can see as we go push this thing forward, the storms or the rain really lights up along the frontal boundary. This high pressure system is bringing in some cooler air, mainly confined to the northern parts of the United States and southern parts of Canada. As we push through this, this evening, this frontal system starts to make its way towards the mountains of western North Carolina, eastern Tennessee, northern Georgia, and the upstate, bringing some light precipitation through, not in the mountains, heavier precipitation in the mountains, but the mountains protect the foothills of Piedmont from heavier precipitation, at least on this particular model run. Then if your attention goes back to the north and west, this little clipper type system will make its way across the northern plains and pick up moisture from the Great Lakes. And then as it dives continuing southeastward, it'll slam up against the mountains, and perhaps some snow is going to be experienced in locations in the spine of the Appalachian Mountains, mainly on the western slopes, getting into some of the locations in the favorable northwest flow snow locations in North Carolina, but pretty much that's going to be confined to the mountains. This particular model run does have some precipitation surviving the mountains and perhaps getting into the Charlotte metro area and through Fayetteville and Wilmington, but probably not. Some of the higher resolution models do not have that. They mainly wring out all the moisture over the mountains. But after that, though, this high pressure system that is centered over the southeastern Canada, this is in a favorable location for snowstorms. However, if you look to the south, there's no low pressure system. We need a low pressure system. And because of the far as, I mean, look how far south this high pressure extends, all the way to the Gulf of Mexico. It's a very big high pressure system. Even though it's in a favorable location, we do not have any surface cyclone genesis towards the northern Gulf, so no storms. This is a shame. But this is going to be a very cold high pressure system, and it's going to linger across the eastern seaboard for some time. We're getting into the Christmas week, and it's still here, bringing cooler than normal temperatures across the vast majority of the eastern seaboard. As we get later into Monday, December 23rd, however, another system takes shape across the upper Midwest, and this is going to bring some precipitation across the Midwest into the southern plains and mid-south. Places like Memphis will experience some pretty heavy precipitation. And this cyclone here, this surface low pressure system centered over the Tennessee River Valley, will make its way eastward and perhaps bring some rain across much of the Carolinas through the afternoon on Christmas Day. So it might be wet, and it's not going to be cold enough for snow, because the traditional rain snow line at 5,400 decameter, or the 5,400 meter thickness line, which is the traditional rain snow line, is all the way up to southern New England. So this is going to be pretty warm. Christmas Day system looks to be pretty warm. Our air masses. So this is again the Euro ensemble prediction system. 5-day running average of the 2-meter temperature anomalies. So again, the cooler colors, cooler than average. Warmer colors, warmer than average. And the 5-day, remember the 5-day means takes out the diurnal processes as well as any precipitation that's like thunderstorms are short-lived. It takes all that out, and it really allows us to figure out where all these large air masses are. So you can see the southern Canada, northern fringes of the United States are in a cooler air mass, while places from South Dakota southward towards the southern plains, the mid-south, and the southeastern United States are warmer than average. Through the 5-day period from December 18th through the 23rd, and as we push this forward, this air mass gets pushed to the east, and the running averages centered on December 24th evening, Christmas morning. Very cooler than average temperatures across southeastern Canada, northeastern United States. That's coincident with where that high pressure was. Remember, it's in a very favorable location. And the reason it's favorable location is because it allows cooler air to be filtered down on the Atlantic side of the Appalachian Mountains. And you can see that very clearly here across parts of the mid-Atlantic into the southeastern United States, across much of North Carolina and South Carolina. Cooler than average temperatures are being filtered through this very cold high pressure system. However, since there's no mechanism for precipitation, there's really not going to be, it's just going to be clear and cold on average. Now we do have that system that is bringing some rain to the area, but that particular system is warmer than what we would need for snow. 5-day averages suggest a cooler than average period across the eastern United States. That doesn't mean we won't have shots of warm air, which is going to happen on Christmas Day, it looks like, bringing rain and not any type of frozen precipitation. But on average, it will be cooler than average across the eastern seaboard in the 5-day period centered on Christmas. So that being said, between now and Christmas Eve, not a lot of precipitation is expected. across the foothills and Piedmont of North Carolina, even the coastal regions, all the rain still appears to be mainly confined to the Mid-South into Texas, Oklahoma region, stretching northeastward to West Virginia. And this is also agreed upon with numerous other models, but these two models are the Canadian models and the GFS models, and they paint a very similar picture, although the devil's in the details. But the overall pattern is pretty consistent between models. So that does it for this video. Thank y'all for watching, and I hope you get something out of it. And I will see you in the next one.